jump into our microbit per second. I'm going to change this from something like 45.6. I'm going to change this to something like 20. So I'm going to be reducing it, essentially cutting it in half. What that's going to make me do is jump into my table here, and I'm going to have to essentially go in and double the values. So what I'm going to do here is go and right click. We'll go to a percentage change. Alternatively, we can just go and keystroke it here and hit E. So let's just do that. Let me grab it here again, and we'll click E. So if we want to go and essentially cut our microbit per second in half, we're then going to have to essentially double everything here in the table. So we're going to go here and do a 100% increase, and we can see here that's going to be essentially doubling everything in the table. And the other effect of changing the microbit per second, it not only affects the table here and my resolution in the table, it also affects the starting here. So we can find right now the cranking injection time, it used to have a scale from 0 to 10,000. So now it's having a scale here from 0 to 5,000. So it auto scales your cranking fuel. And then we can see this was around 6,000-ish. We were talking about that before. Now it's essentially cut this in half, and it's set here at 2,800. So this might be relevant for a cranking fuel. So that jumping back in here, this microbit per second is, again, background multiplier. It affects everything in the background. So if we're cutting it in half to give us more resolution in the table here, we obviously can see we've doubled the values. Now, if I turn down the value here, let's just say values of maybe 10 at a time, our air fuel might jump a point, where before, if I moved the value 1 or 2, it might have jumped a point of air fuel. So now we can be a little bit more precise in our fuel delivery. Again, this is something we absolutely want to do here. Let's click Control S and let's save that. So let's move on here to some other areas that we need to talk about. Flex fuel, we're not going to be doing anything with flex fuel in this video. The nitrous, so we are going to be using nitrous control when we are going to be doing our VTEC tuning. So right now, this table here just represents our low cam. VTEC's going to be off for the next couple videos here so we can get everything mapped out properly. Then we'll turn VTEC on. Then we'll come into our nitrous control and we'll configure this. I'll show you how to do that so that our fuel delivery here is going to come from our table. This is going to be just a percentage multiplier. So it's going to be adding on top of our values we find here from the low cam values. And then here in the spark timing, it'll simply just go and add some additional spark timing if we need it, and we'll be able to pick up some power there. So we'll explore this. Right now we're just going to leave it off just for simplicity's sake, and just kind of keep the video going. And again, we'll cover that a little bit later here in the training course. Now under the trims, first and foremost, we need to go and set up the other aspect, the other portion of the boost comp. So in the table here, by going in and making all of our values here from 0 and higher here in the table, making them all the same, we need to then go in and have a multiplier so that every time we go up and boost, it's going to have a linear multiplier in the background. That's going to allow us to have our table being flat here. This is going to assume that the fuel pressure is rising at a 1-to-1 ratio to our manifold pressure. So the factory fuel pressure regulator is vacuum referenced, and it will rise the fuel pressure 1-to-1. So if let's say our manifold pressure goes from 50, or I'm sorry, for our fuel pressure is at 50 psi base, and we go to 10 psi of manifold pressure, our fuel pressure then should jump to 60 psi. As long as it's following along with that, then our boost comp that we're going to be doing here will be relevant, and we don't have to worry about having any kind of unlinear fuel delivery. If we have fuel pressure problems, that'll start to create some potential unlinearity here, and that can definitely affect how we're going to have our numbers. And pretty clear to spot a trend if we have a problem. So if we have that during our tuning session, we'll talk about it. Otherwise, if we have our values relatively flat here in the table, then we know that our fuel system is linear and the fuel pressure is good. So if we jump here into our trims, this is the table responsible for the background multiplier in our boost comp. So we can see here from full vacuum, negative 13.1 to 0 psi. This represents, if we're just kind of clicking on our table here, this right here represents our vacuum portion, which is going to be here. And what we're going to be doing is having this just ascending trend here. This is kind of the traditional shape of the fuel table. We have all this data that we can manipulate here up or down to get our fuel where we need it to be so the engine runs properly. So the table here should be zeroed out because we have our fuel table here having values that can be varied. Now under boost, we see that we have this flat right here, which we need to change. So from 0 psi all the way up here to 18 psi. This needs to have a multiplier effect. And that by going in and giving this a shape in the table, a line in the table, a linear line, it's kind of a linear multiplier. What we're going to do is pick our point here at approximately 15 pounds of boost. Or if the table here is going to, let's say we scaled it out to...
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.